Hello fellows, Herogon here. September 2024 has been quite the trial by fire for me. Full Sail University had me doing probability and user experience design as my two classes for that month. It's led me to rethink how I operate with my Funlog release schedule, especially since I've been doing my own stuff. See my update video for more info. Other than that, I'm happy to say that I've survived for the most part. October should be easier on my Full Sail workload, as it's back to one class from that point onwards until March 2025. Of course, we all know what right now October 2024 entails, so I'm going to have to prepare for the inevitable Spookagon taking over my recordings for that month. With all that said, let's jump into the Funlog. September 1st saw Shawnthebro going over ending online sessions and exiting them. This included ending online sessions and exiting a session as the server, destroying the sessions to clean them up, and improving online functionality. Much of the logic involved our base game instance code and Unreal Engine's online subsystem. In base game instance.h, we create 4 new functions: end session completed, destroy session, and destroy session completed. We trigger the completed functions when a certain action with a session is finished. We also required 4 more variables, which are completed delegates and completed handles. These handle the completion of ending and destroying our session. The delegate makes sure this can be used to call our respective completed functions once the operation is done. Meanwhile, the handle keeps track of what's bound and what isn't. In base game instance.cpp, we set up our delegates appropriately, similar to search for sessions and join sessions completed. We set these new delegates to call the corresponding functions on completion. Like most functions involving online sessions, we get our online subsystem and the session interface for many new functions. In end session, after getting our online subsystem logic, we've added some logs to test, though that's small stuff. After the logs, we add on end session complete delegate handle, so the handle will track what the delegate is doing. We can now call end session after this, with the name currently using a hard-coded value of my game session. When the end session is finished, the end session completed function will be called. In end session completed, we do the same if statements beforehand. Then we use the online session interface to clear the on-end session complete delegate handle, so we only use things once. After that, we then go to destroy session. In destroy session, we call our logs, add on destroy session complete delegate underscore handle, and then destroy session of my game session. After destroy session is completed, we then go to destroy session completed. In there, we clear our on destroy session complete handle and call debug messages. Finally, in host session, we now call our end session on our else statement when we attempt to create the session. If the session fails to be created, we then end the online session. It's certainly a lot to handle, especially considering that we need 2 players online. But of course, I've had to use the standalone option in the Unreal Editor to help out with that. And while it's certainly been a tough time with that manner of tutorial, especially at the start of the month, I'm glad to have gotten that one done and good. September 8th saw further improvements to online play. This included implementing server travel, opening a level with a listen server, and allowing clients to join the server on a new map. While things are kind of broken right now, we can see further improvements as the tutorials go on. In base game instance.cpp, the travel to session function sees a few code additions. The main ones are print strings to check our debug info, but I cannot show it for worry of showing my IP address. I'll keep everyone safe on this bit. Another line is removing the port number from the connection string, leaving only the IP address. We get connect info and remove the colon and the actual port number. In host session, we have some new logic where we test out the server travel. We use our typical debug strings, then get world and call server travel. With this call to server travel, we have 3 parameters. The name of the level that we want to listen to, absolute, and should skip being notified. The first one is important, as we will open a listen server if we're in a standalone game. Finally, we have 2 small spots in baseplayercontroller.cpp for the code. I have an include line for the widget layout library, so I can call a remove all widgets function for testing server travel. We do this in our begin play, otherwise, all our widgets such as the main menu will be seen in server travel. Going to the default game mode BP, we now connect the end of our event begin play logic to where our level streamed in event logic is. While the progress so far is rough on this part, I'll again remind everyone that online play takes time to improve and iterate. You'll thank Shawnthebro later on once he releases the fighting game framework. I wasn't able to showcase my results of that week due to my menus being a bit different in terms of organization. However, future improvements may fix those issues in time. September 13th was another Tekken-like tutorial from Shawnthebro. This entailed rotating the characters towards each other and toggling 2D and 3D fighting modes. In base game instance.h, we create a new boolean called isFighterMode3D to indicate if we're using a 3-dimensional fighter mode. While it's hard-coded and can't be edited in the Unreal Editor, we can still change its value in the source code itself. we have added a new function called rotate toward opponent 3D in the character.h code. This function will ensure our characters always face each other, no matter what way they're rotated. In the character.cpp, we fill this function out with rotation logic, so our player 2 can be rotated to have their back facing the screen. This is how most Tekken likes appear to do this. We've also added new logic into the tick function in character.cpp. Now, before flipping our characters to ensure they face the correct direction, we cast to our game instance and check if is fighter mode 3D is true. If so, we rotate toward opponent 3D. Otherwise, we continue with our typical character flipping logic. In rotate toward opponent 3D, we first check if the character state does not equal the various jumping states, if we can flip, and if our combo state does not equal wall bounce, which I have commented out at the moment for the latter part. If our character is the other player, we set our controller rotation yaw to true and the character movement's B-orient rotation to movement as false. Then we use an F-rotator variable within, known as look-at rotation, which we use to find look-at rotation of our character's actor location and the other player's actor location. Finally, we set the look-at rotation yaw's value to a certain amount, plus equals. Then get our controller to set control rotation to the variable look-at rotation. Again, note that while the project is meant to use animations for moving in foreground and background, I believe for this time I don't need to use the blend space animations from earlier. It's pretty tough trying to just do the basic minimum for a fighting game framework, but it can be rewarding for the prospect of other users' finalized projects. September 15th saw a minor but welcome addition to the fighting game framework, Subtitles. If anyone knows me, I don't entirely enjoy watching stuff without some form of subtitles or visual wording. It's been something that's hard-coded into my head for a long while, as I'll always go to the subtitles menu before any film that I watch, be on DVD or streaming service. In the fighting game framework, it's pretty simple. We first create a new widget to store our subtitles. In the subtitles element, which is our new widget, we have a background and some text in a canvas panel anchored to the lower screen. In event construct, we set our subtitle text and subtitle background to use two new corresponding variables. These variables will control what text will show up and if our subtitle background should be visible. Next, to create our subtitles and add them to the viewport, we create a new function in base function library. The new function, add subtitles, has two values as inputs. This will go into our two variables from subtitles element, which are exposed on spawn. To use add subtitles, I added it into the entrance sequence for one of my character's animation blueprints. From there, I can use whatever text I like and decide if my subtitle background should be hidden. While a simple start for subtitles, I'm okay with waiting to see what more can be done with my favorite hallmark setting of home or internet videos. September 22nd went right back to improving the fighting game AI. And when I talk about AI, I'm not referring to the generative AI stuff that ChatGPT or certain generative AI applications do, but rather the typical AI that controls our enemies in video games. The main parts involve creating a basic AI task, using custom nodes in a behavior tree, and more artificial intelligence advances. In base AI controller.h, we've added a new function and a new variable. Our function is onPossess, called when the AI possesses a pawn. The variable is a behavior tree that we will use as part of our AI logic. To make the AI behavior trees work, we'll need to have an include line of behavior tree / behavior tree.h, a name so nice I've said it twice. In the .cpp, we set the behavior tree to null pointer, meaning it's empty. Inside the onPossess function, we call a super onPossess, so the original code from the overridden function can still be used. Next, we check if there is a behavior tree assigned to our AI controller. If so, we create a default blackboard, use the blackboard, then run the behavior tree. In the build.cs file, we add the line AI module to our public dependency module names. This will ensure that the new code won't give us errors regarding the code from AI controller. In our blueprints, we've created 3 AI-based parts: a base AI controller blueprint, a behavior tree, which is more visual representation than anything blueprint-based, and a blackboard blueprint. In BP Base AI Controller, we've set the default behavior tree to be BT Base AI. In BT Base AI, we drag from our root to create a selector node, then a play sound node. Finally, in the default game mode BP, our spawn players function has one minor change. Instead of directly calling spawn base AI controller in one of the game modes, we now call its blueprint, which is a child of the code class base AI controller. Definitely a small bit of work done on the fighting game AI stuff, yet there's no doubt there will be more as the weeks and perhaps months go by with Shawnthebro's tutorials. Finally, September 29th gave a new part for the fighting game AI: tasks. With tasks, we can make our AI do things within the behavior tree, such as jumping or movement. So far, it's only that one task of jumping, but it will be good for that moment. First, we add a new C++ class, AI task jump. This is a child code of the BTT task node. Of note, it that this code class is located in a new organization folder called AI Tasks. In AI Task jump.h file, we add an include line for behavior tree /bt task node.h. We have two public code functions in our .h file, uAI task jump and ebt node result type execute task. The latter function is used when the task is executed or run from a behavior tree. In the .cpp file, uAI task jump is empty for the moment. It may be useful to have later on when the fighting game AI is improved upon. Within execute task, we first check if there is an owning player controller. If so, we force the player controller to input jump and finish the task due to a success. We finish our task by using a function called finish latent task and return the ebt node result as succeeded. Otherwise, if there's no owning player controller, we finish the task due to a failure by doing the same logic, but instead returning the ebt node result as failed. Finally, going to our blueprints, we added the new jump task to BT base AI. Practice mode will have an AI opponent by default, per usual fighting game tropes. It's still a long way to go before the AI opponent can be a much smarter fighter. But the journey of 1,000 steps, like I've said, begins with the first step. Overall, September 2024 was my most piled month of the year in terms of workload. Over the past few months, I have focused not on my personal projects, but on my schoolwork and Shawnthebro's fighting game tutorials. Soon I'll likely have to retire fighting game framework coverage once 2024 is over, but I hope everyone can still stick around for further developments. Just because I'm stopping the monthly coverage of Shawnthebro's big fighting game framework doesn't mean I'm stopping my overall work effort. To anyone looking for some encouragement here, keep doing your best and know how to prioritize the important things in life. Credit again goes to Shawnthebro for all his work, which I have enjoyed going through this past month. It has been a lovely backbone for the Funlog content. I hope I can succeed as he has when working with Unreal Engine. With all that said, I hope you liked this video, so comment, like, and subscribe below if you have not already. It helps a small YouTuber out, especially in times like these. I've been Herogon, and you've been you. Thank you for tuning in, and I will catch you all later.